Hi guys, today we're going to go over series and how to do them, like series and summations and stuff. Hold on, let me just get the camera. Okay. Alright, here we go. So there's three different notations that you use when dealing with series. There's A of n, S of n, and the sigma. Now, these two mean the exact same thing. They mean the sum of the series, but this means any one point. Um, yeah, as we move forward, you'll notice that series and sums are different, and series are closer to functions, and sums are just a completely new thing. Okay, let's go to our first type of series slash sum. Now, it's called arithmetic series sum. So, arithmetic series, arithmetic sum. What is it? Well, how do you do it? Well, it's basically it is the equivalent of a linear function in function terms. So a of n, which would be any one point in the series, would be equal to a of 1 plus d times n minus 1. And you're like, whoa, what is that? What are you talking about, Aaron? What does all of this mean? Well, a of 1 is just equal to the first term in the sequence. It's a of 1. You might know functions for starting right at 0 when you count up, but these just start at 1. These series sums, they all start at 1. And then d of n minus 1 is the coefficient, is what's going onward. You're like, how am I supposed to put this in terms of linear functions? Well, do you know y equals mx plus b? It's almost exactly like this. So here it is. Here it is. A of 1 would be equal to b, the y-intercept. D would be equal to m, the coefficient, like the slope. And n minus, which is how far along we've got. Okay, now I'm going to write what you're going to see this as a sum. So sometimes you're going to see this as a sum on a paper. The sigma, this e, that's the most common. It's the most common form in the way that sums are written. So you got one, and you got a 4 on top, say, and then you got a 3n. You're like, what does this all mean? Well, this, the bottom, is where the series or the sum starts. This is where it ends. This is the rule applied to the sum. Observe. Plus times 2 plus 3 times 3 plus 3 times 4. That's it. That's the whole idea of a summation. You take the beginning and the end terms, you apply them all to the rule, and you add them all together. Now, the a of n formula that I showed and how it's similar to a linear function, this thing is how you get any one formula on the arithmetic sequence. So, for example, the d is the coefficient, like the slope. So that d would be 3. That's the d. That's what it is, guys. A of 1 would be basically the first one. So it would be also 3. This is a of 1, though. This is the first term in the sequence. And it's also d times n minus 1. So say I wanted to find the third term in the sequence. So we would sub it out for 3, and we do d times 2 plus a of 1 to get it. So let's go find the third term. Let's go find the third term. I can't wait. Okay, here we go. A of 1, which is 3, plus d, which is this, 3, times n minus 1, which is 3 minus 1, which is 2. So it's 3 plus 3 times 2, which is equal to 3 plus 6, is equal to 9. And if we go to the actual third term in this series, 3, we actually find that it's 3 times 3, which is equal to 9. Actually equal to 9. My God. So to find the sum, you do 3 plus 6 plus 9 plus 12. And that's equal to 30. 30. So, hooray, you found the sum. Congratulations. Now, this only goes up to 4. What if I were to go up to like 65? Because it's out there. That series definitely exists. So, am I just going to write them all out and do all of these? Well, you could, but you don't have to. Observe. This is the rule for S of n. So the sum of any sequence, no matter how high it goes, S of n for any arithmetic sequence. S of n for the arithmetic sequence is a of 1. No, sorry. N times a of 1 plus a of n over 2. This is the rule. So you take the first point, then you take the point it goes up to, you divide them by 2, and then you multiply it by the number of terms. You may think, does this even work? It does. It does. Okay. We'll do it on this one. It goes up to 4, right? Okay, so it's 4 times a of 1 is 3 times a of n, which is 3 times 4 is 12. 3 plus 12 over 2. Oh my God. Okay, here we go. It's 4 times 15 over 2. Oh my gosh. And then it's 15 divided by 2 is 7.5, so 7.5 times 4. And that's equal to 30. Boom. That was the actual sum. Just do it on a calculator. Pause the video if you want to. And you're thinking, okay, so it does work. Everything does sync up. But why, like, conceptually, does this work? And that is because you're finding the average of the highest term and the lowest term. And you're multiplying it by the number of. So, you know how to find the average? You gotta do the sum of everything over the number of, right? Well, now we're trying to find the sum. That's how you find the summation. You do average times number of, and you get the sum. That's exactly what's happening here. You're finding the average, and you're multiplying it by the number of to get the sum. Now, wait, you're thinking like, hold on, wait a minute. I'm just finding the average of the first one and the last one. That doesn't represent every single one in the sequence. But the thing is, about an arithmetic sequence, is that they're the same amount apart. And the thing is about in a sequence where, in a series where every piece of data is the same amount apart, is that you could just take the highest one and the lowest one and find exactly what's in between them, like in an average, and you'll get the right one. You'll get the correct weighed average, because the difference between every single piece is the same. So there's nothing bringing the average in one direction or another because it's too high or too low or whatever. That's what's great about an arithmetic sequence, and that's how you do it. So you got it down there. There's the first rule. Here's the second rule to find the sum. Here's the first rule for any one point, and you got it. Hey, I got some great news. This is just one type of sum. I'm going to make another video on how to do the other type, which is a geometric sequence. So tune in when I do that.